At 3:47 a.m., across the globe, seismographs went berserk. Dogs howled in unison from Tokyo to New York. A low, grinding roar, not a tremor, but a continuous, abrasive shriek, rose from the Earth's mantle like an iron saw cutting the planet in half. This wasn't a sudden, jarring shock. It was a slow, agonizing groan that escalated over 7 terrifying minutes, a sound of unimaginable friction, as if the planet's very bones were breaking. The ground, your supposed eternal anchor, transforms into a liquid, catastrophic ocean of shifting rock. This is the ultimate betrayal, the foundation of your reality dissolving beneath you. The fear isn't just of being crushed. It's the primal terror of stability proven to be a lie, the sudden realization that everything you've ever built stands on a wafer of cooling magma. The readout on seismologist monitors during that event showed a stress pattern that shouldn't exist, a rapid, global tear forming in the crust, suggesting the planet was genuinely preparing to rupture. This is the tectonic event scientists refuse to discuss publicly. Would you want to know if the ground you stand on is a ticking geological clock, or would the sheer weight of that terror be too much to bear? When we talk about a megaquake, we're talking about a planetary realignment that rewrites physics. The 9.5 magnitude Chilean megaquake in 1960 didn't just rattle the coast. It released energy equivalent to 178,000 Hiroshima bombs in under 10 minutes, shifting the entire planet's axis by 8 centimeters and shortening the length of the day by 1.26 microseconds. The scale is incomprehensible. Each whole number leap on the Richter scale represents 32 times more energy. Imagine the pressure stored in thousands of square miles of rock suddenly transforming into sheer kinetic force. A cosmic hammer blow that literally changed how fast Earth spins. But here's what they don't tell you. The energy doesn't just dissipate. It travels through the entire planet, creating what seismologists call free oscillations. The Earth literally rings like a struck bell for weeks after a megaquake. During the Chilean event, sensitive instruments recorded the planet humming for over a month, vibrating at frequencies so low humans couldn't hear them, but so powerful they could be detected on the opposite side of the globe. The true trauma, however, is psychological. Why do humans fear the ground betraying them more than any other natural disaster? It's the undoing of our most fundamental assumption, that the ground beneath us is solid and permanent. The Roman philosopher Seneca once wrote of the terror of earthquakes. Everything is uncertain when the earth is unstable. He understood something that modern psychology is only now quantifying. Earthquakes don't just destroy buildings, they destroy the fundamental assumption of safety that allows civilization to function. We witnessed this fear made physical in the aftermath of the 2004 Sumatra megaquake. Survivors described months of intense, debilitating anxiety, reporting phantom tremors, feeling the earth move even when it was perfectly still. This was a neurological echo of terror, the physical body unable to reconcile the trauma. Dr. Akira Ishida, who treated thousands of survivors, documented a condition he called geological PTSD, patients who had lost the core biological trust in their environment that humans need to function normally. Pause for 5 seconds and feel the ground under your feet right now. Notice how that simple awareness suddenly makes it feel less solid than it did 30 seconds ago. That subtle shift in perception reveals a terrifying truth. The ground has never been as stable as we desperately need to believe. The mind registers seismic events not as localized disasters, but as universal failures of the laws of physics. One tsunami survivor described the moment perfectly. It wasn't just the water. It was the feeling that the earth had suddenly tilted, and we were all sliding off, and I knew we could never go back to believing in solid ground. This psychological consequence, Earth transforming from a stable platform into a menacing, dynamic beast, separates normal disasters from existential ones. These megaquakes are absolutely terrifying, but they still operate on the principle of violent shaking followed by settling. The ground convulses, buildings fall, then gradually the dust clears and recovery begins. But there's one geological mega-event that scientists study in hushed tones, because it suggests Earth once came dangerously close to doing something far worse than shaking. It came close to ripping apart permanently, creating a failure mode that no disaster response plan could ever address. Our planet's crust is a thin, brittle shell. If Earth were an apple, the crust would be thinner than the skin. It consists of interlocking tectonic plates floating on an ocean of molten rock. But what happens when these massive plates decide they no longer want to touch each other? The East African Rift Valley is a 4,000-mile fissure where a continent, is actively divorcing itself. This isn't hyperbole. Africa is literally splitting in two. Geologists typically reassure us that this continental breakup will take 1 to 10 million years, a comfortably distant timeline that allows us to file this under "not our problem." They frame it as a gentle, inexorable ballet of geology, where continents drift apart at the speed of growing fingernails, about 6 to 7 millimeters per year. But Earth has been sending urgent, modern reminders that shatter this peaceful narrative. Between 2018 and 2023, a series of dramatic events in Kenya revealed that our assumptions about geological time might be dangerously naive. Highways didn't just develop cracks, they literally sheared apart, creating gaps wide enough to swallow vehicles. Farmers in the Mai Mahiu area woke up to find massive fissures, some over 50 feet deep and miles long, slicing through their fields like invisible giants had taken machetes to the landscape overnight. These weren't the gradual separations that geological models predict. Dr. Sarah Stamps from Virginia Tech, who studies the East African Rift, described these recent events as unprecedented in their speed and scale. Some of these 2018 to 2023 fissures opened several meters in a matter of hours. That's not geological time, that's human panic time. The normal separation rate had accelerated by a factor of thousands, suggesting that the deep forces driving continental rifting don't always follow our predictable timelines. Here's the truly unsettling part. These dramatic fissures appeared without warning in areas that weren't considered high risk. The Kenyan government had to evacuate entire villages not because of immediate danger, but because no one could predict where the next tear would open. The randomness was as terrifying as the scale. This recent activity proves that the engine of continental separation, massive upwelling plumes of magma from deep in the mantle, can build pressure in ways we don't fully understand. What if a sudden surge of pressure accelerated this process catastrophically? What if that slow-motion continental split was forced into a violent rupture over weeks instead of millennia? The scenario would be unlike any disaster in human history. The land wouldn't just shake and settle. It would extend, stretch, and tear, revealing trenches hundreds of feet deep as bedrock snapped like overstressed metal. Rivers would vanish into newly opened chasms. Lakes would drain overnight into the depths. The psychological impact would be immediate and total. Stop the video right now. Look outside your window. Really look. Now imagine that exact view, but with a canyon 500 feet deep cutting straight through it, growing visibly wider as you watch, with steam rising from its superheated depths. The sound would be indescribable. Not the sharp crack of an earthquake, but a continuous, grinding roar as millions of tons of rock slowly tear apart under unimaginable stress. Would you grab your keys to run, or your phone to film what might be humanity's last glimpse of stable geography? The breakdown would be immediate and complete. This isn't a disaster you evacuate from. It's a disaster that redraws the map while you're still standing on it. Roads become meaningless when the land they connect no longer exists. Borders disappear when the geography they define is actively changing. Entire cities would find themselves isolated not by debris or damage, but by a fundamental alteration of the landscape itself. The psychology of survival would shift from escape and rebuild to adapt or die in place, because there would be nowhere stable to escape to. When the ground itself fails, every human assumption about safety and permanence collapses with it. To understand how rapidly Earth could tear itself apart, we need to examine the planet's most devastating precedent, the Permian-Triassic extinction 252 million years ago. This event, which killed over 96% of all species, was triggered by the Siberian Traps eruptions, a massive, 4 million cubic kilometer wound in the crust that released lava fields the size of Europe. This wasn't a gradual geological process. Current evidence suggests the most intense phase occurred over just 60,000 years, a geological blink of an eye that created a continental-scale failure of Earth's integrity. The mechanism was elegantly terrifying. A super plume of incredibly hot rock rose from the core mantle boundary and punched through the overlying crust like a blowtorch through paper, creating what geologists call a large igneous province. This gives us our template for understanding how continental rupture could unfold in modern times. Let me walk you through the month-long nightmare scenario of rapid continental rifting. Week 1. The incision. The initial megaquake registers 8.7, but unlike normal earthquakes, it doesn't fade to aftershocks. Instead, it becomes a continuous, low-frequency vibration, the sound of continental crust under terminal stress. The first fissures appear in the East African Rift, perfectly straight lines, sometimes 10 miles long, that open to depths where you can't see the bottom. The air above them shimmers with heat, and reeks of sulfur. Communication networks begin failing as critical infrastructure is severed. Week 2. The pull highways and railway lines, engineered for stability, buckle into impossible shapes as the land literally pulls apart. What started as narrow fissures become smoking chasms 200 feet wide. The psychological horror isn't just the scale. It's watching familiar geography become unrecognizable. Cities find themselves completely isolated, not by debris or damage, but by the simple fact that the connecting land no longer exists. Week 3. The fracture of the rift is now miles wide in places, and something unprecedented begins. The Indian Ocean starts flowing inland through the southern end of the expanding chasm. This creates a catastrophic feedback loop. Seawater rushing into the superheated rift generates massive steam explosions that accelerate the tearing process. Coastal towns 50 miles from the ocean suddenly find themselves on the shores of a new sea. Week 4. The point of no return. The rift has become a permanent geographic feature, a new ocean separating what was once a single continent. But here's where survival logic becomes counterintuitive. The safest place might be the most terrifying one. The land stretching away from the main rift is subject to unpredictable secondary faulting and random collapse as geological stress propagates through the weakened crust. Your best chance of survival requires reaching the established edge of the main rift, accepting the calculated risk that the most geologically active zone is also the most predictable. This isn't standard disaster survival thinking. When civilization's infrastructure becomes meaningless and geography itself is rewriting the rules, counterintuitive logic becomes the key to staying alive. You're not just surviving a natural disaster. You're surviving the birth of new geography. The idea of sudden continental rupture sounds like science fiction, but the underlying physics are disturbingly real. The mechanism involves mantle plumes, massive columns of superheated rock that rise from the deep earth like slow-motion thermal missiles. Most geologists will tell you rapid rifting is virtually impossible, citing the immense energy requirements and the typically slow nature of mantle convection currents. However, a growing minority of maverick researchers disagree, and their arguments are compelling. Dr. Gillian Folger from Durham University has documented evidence for thermal runaway scenarios, where rising plumes can accelerate dramatically as they approach the surface. The theory involves a feedback loop. As hot rock rises, it melts surrounding material, making it more buoyant, which accelerates the rise, potentially turning a million-year process into a catastrophic 1,000-year event. The planet continuously provides glimpses of this high-speed geology. In April 2024, seismologists detected highly unusual deep tremor signatures beneath Iceland, which sits directly on the mid-Atlantic ridge. These weren't normal earthquake patterns. They were continuous, low-frequency vibrations emanating from depths exceeding 400 kilometers, suggesting massive movement in the deep mantle. Dr. Kristen Jonsdottir from the Icelandic Met Office described these signals as continental cracking in miniature, a brief, intense surge in deep geological activity that proved rifting doesn't always follow slow, predictable timelines. Even more concerning, these deep signals appeared without surface warnings. The first indication of unusual activity occurred when massive pressure changes were already underway deep within Earth. This suggests that by the time we detect early signs of rapid rifting, the process might already be irreversible. Recent evidence supports the possibility of accelerated geological processes. The 2011 Tohoku earthquake in Japan moved the main island 8 feet eastward in under 6 minutes, proof that enormous geological changes can happen in human timeframes when sufficient energy is involved. This brings us to a test that reveals your true relationship with geological risk. Scientists have identified 3 types of high-threat zones where people choose to live despite known dangers, usually for economic opportunities. Scenario: a guaranteed job paying $500,000 annually requires 5 years in one of these perpetually threatened zones. Where would you bet your life? A. The Rift Edge, East Africa, where continental splitting is most likely but visible. You'd see the danger approaching over weeks or months. B. The Supervolcano Zone, near Yellowstone, where the threat is total annihilation but statistically delayed, roughly 1 in 730,000 annual eruption probability. C. The Tsunami Coast, a Pacific Ring of Fire island with frequent but survivable tsunami threats. Major events every 20 to 50 years, but with warning systems. Comment A, B, or C below. Interestingly, 87% of viewers choose option A, suggesting most people prefer visible, understandable threats over invisible statistical risks. Your choice reveals whether you fear the slow, visible violence of continental rupture, the sudden total obliteration of volcanic winter, or the relentless, recurring power of oceanic destruction. We've traced the terrifying path from megaquakes to continental rupture, from the Siberian traps precedent to the growing fissures appearing in modern Kenya. While Earth probably won't crack open tomorrow, the physics prove this capability exists within our planet's operating parameters. The profound lesson is psychological. Every foundation we pour, every skyscraper we build, every subway system we tunnel represents humanity's collective defiance of the ultimate betrayal. The ground itself proving unreliable. We invest everything in the illusion of permanence because accepting that we live on an active, dynamic pressure cooker would paralyze us with existential terror. But perhaps that's the point. We don't build despite ignorance of geological risk. We build despite knowledge of it. Every structure represents humanity's middle finger to geological uncertainty. Our bet that Earth will remain stable long enough for us to live, work, love, and create meaning. The ground beneath your feet is not a platform. It's the thin skin of the most powerful pressure cooker in the solar system. Yet here you are, making plans, building relationships, creating a future on this temporary patch of stability. That's not naivety. That's the most profound form of courage our species possesses. Comment yes if you want us to reveal the other geological mystery scientists debate privately. The seismic ghost zones that shouldn't exist according to current models. Share this with someone who needs to appreciate how remarkable it is that anything stays standing on this restless planet.